Now the next chapter is chemistry of group 17 elements. This is the outline of long form of periodic table. In periodic table altogether there are 18 groups and 7 horizontal rows, and the position of these elements, group 17 elements, is these elements are placed in P block. There are 4 blocks, S block, P block, D block and F block. So these elements placed in P block, and in 17 group elements are fluorine, chlorine, bromine, iodine, astatine and tennessine. Now about the occurrence of group 17 elements. These halogens, that is fluorine, chlorine, bromine, iodine and astatine, out of these various halogens, astatine and tennessine, these are the radioactive and man-made or artificial elements. Rest of the elements, that is fluorine, chlorine, bromine, iodine, occur in nature, and fluorine occur in combined state as a fluorospar, that is CaF2, cryolite, Na3AlF6, fluoropatite, 3Ca3PO4 twice, that is calcium phosphate, calcium fluoride. So this is the formula for fluoropatite. So fluorine occur in nature in the form of these 3 ores. Chlorine occur in the form of carnallite on earth crust. Its composition is KCl, MgCl2, 6H2O. So bromide salts found in the small extent in seawater, whereas iodides found in seaweeds. Why these are called as halogens? Reason is, the Greek meaning of halogen is, halo means sea salt and gene means born. As most of the elements occur in sea salt, these are called as halogens. Next is electronic configuration of group 17 elements. First element is fluorine. Its atomic number is 9 and its electronic configuration is, in penultimate shell there are 2 electrons, 1s2, and in valence shell there are 7 electrons. Their general electronic configuration, valence shell general electronic configuration is ns2np6, ns2np5, not 6, ns2np5, it should be 5, ns2np5. And therefore for fluorine, in penultimate shell there are 2 electrons and in valence shell there are 7 electrons, 2s2, 2p5. Similarly chlorine, atomic number 17. In inner shell there are 2 electrons, 1s2. In penultimate shell there are 8 electrons, 2s2, 2p6. And in valence shell again there are 7 electrons, 3s2, 3p5. Bromine, atomic number 35. So in inner shell altogether there are 10 electrons, 1s2, 2s2, 2p6. In penultimate shell 18 electrons are there, 3s2, 3p6, 3d10. And in valence shell there are 7 electrons, 4s2, 4p5. Iodine, atomic number 53. This is the inner shell. Configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. In penultimate shell again there are 18 electrons, 4s2, 4p6 and 4d10. Whereas in valence shell again 7 electrons are there, 5s2, 5p6, 5p5. Astatine, atomic number is 85 and inner shell electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14. So this is the inner shell configuration. In penultimate shell again 18 electrons are there, 5s2, 5p6, 5d10, and in valence shell again 7 electrons are there, 6s to 6p5. So outermost or valence shell electronic configuration is ns to np5. It means last electron enter in p orbital, and therefore these elements are placed in p block. And in outermost shell there are 7 electrons. They require 1 electron to complete octet, and therefore these elements are highly stable. They have a tendency to gain 1 electron, and they are highly reactive. And acquire a stability. Halogens are highly reactive and they acquire stability by means of completion of octet. Now trends in physical properties. These are the elements: fluorine, chlorine, bromine, iodine, astatine and tennessine. First important property is atomic size, atomic volume and density. Atomic size, atomic volume as well as density increases from fluorine to iodine, as astatine and tennessine, these are radioactive and short-lived elements. Less chemistry is available with these elements. Okay, from fluorine to iodine, atomic size, atomic volume and density increases. Now ionization enthalpy. Ionization enthalpy, it is the amount of energy required to remove electron from outermost shell of isolated gaseous atom, and it is related to the atomic size. Greater the atomic size, lesser is the ionization enthalpy, and therefore from top to bottom, as atomic size increases, ionization enthalpy decreases. So ionization enthalpy decreases from fluorine to iodine, fluorine, chlorine, bromine, iodine. It decreases from top to bottom. Similarly, electronegative characters also depends upon atomic size. Smaller the size of atom, greater is the electronegativity, and fluorine is having highest electronegativity, that is 4, and electronegative characters also decreases from fluorine to iodine because atomic size increases from fluorine to iodine, and therefore electronegative characters also decreases. Now metallic and non-metallic characters. So actually these elements, halogens, these are non-metals, and non-metallic characters decreases down the group. It means fluorine is having most non-metallic character, whereas iodine is having least non-metallic character. So non-metallic character decreases from fluorine to iodine. At the same time, metallic characters increases from fluorine to iodine. So iodine is having more metallic characters, whereas fluorine is having more non-metallic characters. Next is melting and boiling points. So from fluorine to iodine, melting and boiling points increases. Basically these elements have low melting and boiling points, and from fluorine to iodine, that is from top to bottom, melting and boiling points increases. The next property is electron affinity. Electron affinity or electron gain enthalpy, it is a tendency of an element to accept one electron and form a negative ion. So the amount of energy released when particular atom gains electron and forms negative ion, this is the electron gain enthalpy or electron affinity. And electron affinity, it decreases from top to bottom. So from chlorine to iodine, electron affinity decreases. Basically trend should be like this: from fluorine to iodine, electron gain enthalpy, it should decrease, and fluorine should have highest electron gain enthalpy or electron affinity, but exceptionally chlorine is having highest electron affinity. Okay, and chlorine is having highest electron affinity, or chlorine is having more electron affinity than the fluorine. Reason for this is fluorine is having too small size, and therefore its electron affinity is less, than the chlorine, and from chlorine to iodine electron affinity further decreases. Then oxidizing power. Basically the halogens are good oxidizing agents, but oxidizing character decreases from fluorine to iodine, and fluorine F2, it is the strongest oxidizing agent, and it is due to fact that it has a low bond dissociation energy, and so when bond is dissociated and fluoride ion is formed, so the resulting fluoride ion is having high heat of hydration, and because of high heat of hydration of fluoride and low bond dissociation energy of fluorine molecule, fluorine is the strongest oxidizing agent. About the physical state, at room temperature, fluorine and chlorine, actually these are the diatomic gases. These are the two diatomic gases. All the halogens exist as a diatomic molecules, and fluorine and chlorine, these are the gases at room temperature. Bromine, it is a liquid at room temperature, and iodine, it is a solid at room temperature. About the color, fluorine gas has a pale yellow color, chlorine gas is greenish yellow, bromine, it is a liquid which is brown in color, and iodine, it is a violet solid. So this is about the color, and this is the table which supports the physical properties. These values supports the trends in physical properties. Atomic number, this is the atomic number increases from fluorine to iodine. This is the electronic configuration. Atomic mass increases from fluorine to iodine. Atomic radius also increases from fluorine to iodine. Then ionic radius also increases from fluorine to iodine. Electronegativity, fluorine is having highest electronegativity of 4, and iodine has the electronegativity of 2.5. Electron affinity, you can see here, chlorine is having highest electron affinity, and from chlorine to iodine electron affinity decreases. Then ionization enthalpy, it is highest for fluorine, and fluorine to iodine electron affinity, ionization energy decreases. Then bond energy, it is lowest for, actually for fluorine it is 158.8, and for iodine 151.5. they have comparable bond energies. From fluorine to chlorine to bromine, bond enthalpy increases, bond energy increases, and for iodine it is lesser than the bromine. The boiling point and melting point increases from fluorine to iodine. Standard electrode potential, positive value, decreases from fluorine to iodine. Then physical state, so as I said, fluorine and chlorine, these are gases, bromine is liquid, iodine is solid. And color of gas, already I told you, fluorine is pale yellow gas, chlorine is greenish yellow, bromine is a liquid which is orange red colored, and iodine is a it's a violet color, it has a violet color. Similarly, color of liquid, in liquid state fluorine is yellow, chlorine is also yellow, bromine is having reddish brown color, and iodine is having dark violet color. So this is about the physical properties and trends of physical properties in periodic table.